In today's lesson, we are going to take a look at our comparative anatomy foldable. So remember, when we're talking about different pieces of evidence for evolution, right, which we can use anatomy as one of those pieces of evidence to show how species have changed over time, and also to show how closely or distantly related species are to one another. So we're going to start with our homologous structures. So I'm going to turn my notebook sideways. So homologous structures are structures that look the same but have different functions. Okay, so same structure, different function. Homologous structures also imply evolutionary relationships among the species that have those structures. So different species, right, possess homologous structures because they are descended from a common ancestor. But, right, those structures look different because they are adapted for different uses. Okay? So, for example, right, we have, right, the human arm. We have, right, like, I don't know, this is a cat foot, and then this would be probably like, I think this is a whale arm. So it's just the bones, but they're all the same bones. So radius, ulna, phalanges, right? If we were to color code this, they'd all be the same bones. So this implies that there is a common ancestor and a close, right, evolutionary relationship among these species. Because again, it's more likely that all three of these species share a common ancestor, and that's why they all have the same bones, versus saying, oh, all of these species independently develop the exact same bones, right? It's much easier to say they have a common ancestor that they inherited those structures from. So the second type of structure are analogous structures. So analogous structures are structures within different species that are adapted to perform the same function. So different structure, same function. Analogous structures do not imply evolutionary relationships. So these organisms, right, they have they have different structures that perform the same function, so they are not closely related because they are different structures. So again, the wing of a bird and the wing of a bug, they have the same function, but they developed in different ways, right? Feathers versus, cartilage. So these different species develop analogous structures because of similar selective pressures from their environment that they are living in. So for this example, we're talking about flight. So birds or bats or insects, right? Flight was an advantage. So they all, in different ways, developed wings. So they have the same function, right? But they are different structures. So a bird and a bug, right? They are not very closely related, right? And then we have our third type of structure, which are vestigial structures. So vestigial structures are structures within an organism that are functionless, right? They serve no point, okay? Vestigial structures do imply evolutionary relationships, okay? So they represent a loss of a function that is not needed by that descendant species, right? The newer species. So, for example, even humans, right? We have vestigial structures within our body, like our tailbone. Okay, we don't need a tailbone. We do not develop a tail. Okay, it no longer serves a function. If you have a dog or a cat, next time you look at their paws, they have what's called a dew claw, right? It's like really, it's kind of higher up from their four fingers. Dew claws are vestigial structures. They serve no purpose, okay? But they do represent a function that an ancestral species probably needed, okay? But the newer species, the descendants, they don't need those structures, so they are vestigial, okay? They are functionless. So that is it for our notes on comparative anatomy, right? Which again goes along with our discussion of evidence of evolution. So if you have any questions or concerns, just let me know.